This video was produced in the framework of the Climed-Fruit project and will allow you to discover one operational group involved in the project and the different results and testimonies that resulted from it. Starting, a little tutorial to remind you how to put YouTube subtitles in your language. First, click on the Settings button and on the Subtitles button. You can click on the auto-generated proposal. Once it is done, click again on the Subtitles button. Now choose your language. Here we are, now you are ready. Let's start with the general presentation of this operational group.
Okay, so the name of the operative group we are taking the information from today is VIRECLI, which means basically viticulture resilient for climate change. That is the acronym, and then I will explain a little more in details. So this OG has been working during 3 years, maybe a little more due to COVID stuff, you know. And we had 8 partners in the group, and some of the partners are the universities. Of course, today we have around the table Professor Poni and Davide Modena from Piacenza and Milan University, but there is also one university from Pavia, which is also in the Lombardy region near Milan, and they are very good in what is related to soil and to soil management, hydrological behavior of the soil and this kind of stuff. And then, of course, we had some wine growers. So today you're going to see the testimony of 2 of those wine growers. So we are really pleased about that. And we have been working in 2 geographical areas that are both in the north of Italy, as you can see in the slide. So that would be the Lombardy region. That was also the, let's say, the sponsor of this operational group. And the 2 regions are the Franciacorta, which is a region that is specialized about sparkling wine product. And then we have Oltrepo Pavese, which is more down south, but today we are not going to speak about Oltrepo Pavese. Regarding Franciacorta, David is going to give us some more info when he speaks about the context and especially about the problem of water that they are facing. So I will leave it to David, who is much more technical than I am. And this is basically the subtitle to understand what is VIRECLI. So VIRECLI was about precision viticulture, and I've been targeting all these, let's say, macro areas that are water, freshness, soil management, and canopy management. And today we're going to talk about precision irrigation with Davide, and also about late pruning with Professor Poni. But we also have been speaking about new rootstocks, also with the University of Milan, and especially linked to the wine freshness. And there were also some studies about the soil management linked to soil conservation, erosion, and capacity, hydrological behavior and stress behavior. And also some more precision viticulture about fertility. But today we choose 2 practical solutions based on the interest we think, and also on the fact that they have concrete results to tell to everybody. So the first one, the first experiment practice would be about late winter pruning, which has 2 aims linked to climate change. The first one is to prevent the spring frost damages. And the second one is to maintain the freshness of the grape by delaying the ripening. This was an experiment conducted by University of Piacenza, Università Cattolica del Sacro Cuore is the correct name, and by the team of the Prof. Poni, and on this Castello di Bussago la Santissima, which is this place, very nice place. And Okay, so now we're going to start with a short video, which is a testimony of Sabrina Gorzio. She's the enologist and she's the owner of this winery, Castello di Bussago, La Santissima. It's, let's say, quite a small medium winery who has 21 hectares. They work in organic and they produce traditional method sparkling wine and also some still wines, but let's say that their core business is sparkling wine. And she's gonna explain why they need to delay ripening.
Un piacere per noi aver aderito a questo progetto, anche per noi è fondamentale, questo ci sta a cuore, questa tematica importante dei cambiamenti climatici. Io sono enologa e produttrice della cantina Castello di Bussago, siamo a Bussago, nella zona più a est della Franciacorta, siamo in un terroir particolarmente vocato ma importante perché proprio siamo in un anfiteatro di colline. Castello di Bussago è una realtà molto recente perché nasce nel 2007, è una piccola cantina, diciamo a livello quasi una conduzione proprio più artigianale, sono circa 21 gli ettari, quindi veramente pochi, però abbiamo la fortuna di avere tanti di questi vigneti terrazzati e pedecollinari. In questa immagine appunto ho voluto rendere due scorci perché siamo proprio avvolti in questo anfiteatro di colline. Produzione di uve Franciacorta, Chardonnay e Pinot Nero e poi anche qualcosa vitato da rosso per il Curte Franca. Tutto a regime biologico e in questi anni, dalla nostra prima vendemmia ad oggi, abbiamo visto che le anticipazioni delle date delle vendemmie purtroppo sono sempre più precoci, infatti ci troviamo spesso a raccogliere ai primi di agosto, intorno al 6 di agosto. Siamo tra le cantine franciacortine quelle più precoci ad iniziare proprio con le prime maturazioni. Questo anche dato sicuramente dal fatto di avere molti vigneti esposti, soprattutto per i nostri terrazzamenti, l'esposizione e l'illuminazione di questi vigneti. E la fortuna di essere in questa zona, di essere tra queste vallate, ci permettono di avere degli sbalzi termici importanti tra il giorno e la notte, quindi ad avere anche delle qualità di uva importanti, soprattutto con dei tenori acidici elevati. E la volontà nostra di anticipare, di cercare di raccogliere il momento ottimale, appunto ci porta spesso a raccogliere proprio anche nella prima decade di agosto. Ovviamente questo progetto a noi sta a cuore per cercare di capire come poter posticipare, se si può intervenire appunto su un ritardo, perché comunque potrebbe anche noi aiutare a mantenere la qualità e la filosofia della nostra azienda, proprio per rispettare comunque tutto quello che a noi sta a cuore rispetto del vitigno e dell'ambiente e della qualità proprio dell'uva intrinseca che ci porta. Questo è quanto appunto dal più piccolo panorama della mia cantina e poi lascio parlare appunto chi ha seguito questo progetto nei nostri vigneti.
Now that you know more, let's see the results that came out of this project.
Tommaso Frioni, sono ricercatore presso l'Università Cattolica del Sacro Cuore a Piacenza. In maniera molto essenziale che cosa si intende per potatura tardiva. La potatura tardiva, per potatura tardiva intendiamo essenzialmente un adattamento di quella che è la normale tecnica di potatura invernale. Cosa consiste questo adattamento? Qui nelle foto vediamo un cordone speronato e vediamo che in questo cordone speronato la potatura non è stata eseguita, si attende essenzialmente il germogliamento e si effettua una potatura, la stessa identica operazione di potatura, in fasi successive al germogliamento. Si basa e si fonda, innanzitutto si parla di potatura tardiva quando appunto arriviamo intorno al germogliamento, dal germogliamento in poi, nelle porzioni apicali dei tralci. In cosa consiste, in cosa si basa la potatura tardiva? La potatura tardiva si basa su una peculiarità della vite, cioè l'acrotonia, il comportamento naturale della vite di favorire i germogli distali di una pianta, di un tralcio, nello specifico. Qui in questa pianta vediamo appunto questa vite non potata che ha sviluppato i germogli nella posizione apicale, okay? Mentre nelle posizioni basali, se vediamo nel dettaglio, anche nella foto a sinistra lo vediamo bene, questi nodi basali sono rimasti inibiti. Perché? Cosa succede se noi andiamo a potare quindi in questa fase? Abbiamo praticamente questi nodi basali, che sono quelli su cui poi noi voglieremo costituire gli speroni, che risultano appunto ancora in uno stato molto più indietro, molto più arretrato rispetto a una vite potata normalmente in inverno.
And so we thought that, well, in viticulture it's very difficult to invent something new. Sometimes we are actually reusing in a different way old things. This is my perception. And this is, you know, a slide showing 3 different cases where you can appreciate the acrotony phenomenon, where regardless of the length of a productive unit, here you have a spur, this is a long spur, this is a cane, but you see that all of the time, the apical node is actually having a shoot that is more advanced in growth than the proximal shoots, okay? And this is a general law. And this kind of principle has been used, and now I'm actually coming to the real point. It has been used to, let's say, propose another version of a late winter pruning, see, late winter pruning, that can be applied either on a spur prune cordon or also on a Guyot system, of course, using different approaches. And the best protocol that you should follow if you want to use this on a spur prune cordon is actually doing it in 2 different times. In winter, anytime you like, I mean, you can do what it's a mechanical pre-pruning. As you can see here, this is an over-row pruning machine that is actually, you know, asked to just shorten the canes at approximately 7, 8, 9 nodes, okay? And then you just have to wait. You have to wait until, due to acrotony, the bud burst starts from the apical nodes, and at that point, you go out there and you do what it's basically the hand finishing, right? Because what you need to replenish is a spur, and so you will be doing the hand finishing. The main problem is, how long should I wait before doing this? And here we have done a lot of work, and also a lot of work has been done around the world on the technique. The rule is that you can wait until these shoots have reached basically the stage of a couple of unfolded leaves. Well, that means they should be 4 or 5 centimeters in length, no more than that. You don't have to go over that. And this is just, you know, if you start from this point and you go clockwise, you see basically all the different steps. This is the hand finishing, and here you see that there is a comparison of the same vineyard between the standard winter pruning, you see is very well ahead in growth, and the delayed winter pruning that is definitely slower. But you know, the problem is, you know, you do this kind of work, you do this kind of studies, but actually to prove that the technique is working, you actually need a frost damage. And well, sometimes when you say that, well, people are staring at you and telling, hey, don't try to do this. But actually in 21, I guess, at the Rufino estate in Tuscany, they actually happen to be exactly in the right situation, because on April 7 and April 8, they had a fairly severe frost, and but they were actually able to apply the technique on a given number of rows, and they applied, you see, T2 pre-pruning winter and finished the 22nd of April, okay? I mean, leaving a fairly low cane number per vine. As you can see, you can count the canes per vine. There are 4 or 5, or just you know, having a sort of less selective winter pruning, and the finishing was done the 22nd of April. Of course, you know, when the frost came, well, there were some developed shoots that were actually killed. But, you know, the principle is that the basal nodes at that point were not developed yet. And so basically you have a reserve of nodes that will replenish either the growth and especially the yield. Because you see here, this is treatment 1 that was hit by the frost, and this is the crop. Whereas in these 2 treatments, of course, the difference is huge. And actually, treatment number 3 preserve the regular crop they have in that place. Just to go a little bit faster, well, the second option, of course, you can do this also on a Guyot prune vine, on a cane prune vine. Although, again, you need to take into account that, you know, the final goal that you have is different. The final goal is not just having spurs on a cordon, but the final goal is having a new long cane that needs to be positioned on the main wire, okay? So again, what we do here on the cane prune vine, we propose again a 2-step procedure. For instance, in winter, anytime when you have time, you do a sort of pre-pruning, so you remove the older cane, and then you may want to select a couple of canes that will actually be used for this kind of work. And the very important thing is that they have to be as long as possible. Because you see, you need to have the extra length necessary actually to allow, you know, the early bud burst, and then you are actually shortening the cane at the proper length, okay? Well, actually, the VIRECLI project has been centered around this technique, and here you have. Well, by the way, we were testing a couple of different approaches. There was a delayed and a very delayed winter pruning versus a standard winter pruning. But to make it short, what we were able to achieve is, for bud burst, you see that the delay versus the control, the test is the control treatment for each year, okay? You see the delay in bud burst went from 4 to 9 days. But apparently you see that actually the delayed increased with the season, and I do have an explanation for that, but for now we just observe that the delay at bloom increased up to 22 days. And then depending on the year, depending on the season, of course, as Vincenzo was saying, well, the season that you get after you do this is quite important. But for instance, you see that when we get into harvest, in 1 year, we were able to maintain a 20 days delay. That is really notable. And whereas the delay was different in the other 2 seasons. But, you know, well, this is just, oh, you should take a look at this, right? This is an image of the 2 canes, okay? You see they have started to grow, and this is the right stage where you grab one of the 2 and you shorten it, and you actually drive it onto the horizontal wire, whereas the other can be actually spurred. And this is one of the most, I would say, evident results. This is a seasonal pattern for the acidity components, okay? So this is total acidity on the left for the 3 years. This is tartaric, and this is malic, okay? And so you see that depending on the, oh, I realize that basically these 3 are the same as those 3, so there has been probably a type or a miscopying, but anyway, just taking a look at the first two, all right, yes, of the first 2 years, you see that in 2020, well, you see that the possibility to delay the acidity accumulation is huge. And if you look at this, you see that, for instance, when in the control treatment, the acidity was already around 10 grams per liter. In the other two treatments, they were still 25. Okay, and that was mostly due to the malic acid, actually. Okay, and so there is this possibility to actually delay the acidity. However, most importantly, you do not have to forget that if you remove with the end finishing an excessive amount of leaf area, you will get this sort of dramatic effect. In other words, if you wait too long and you remove a lot of leaf area, you will have a depression in the yield in the current season because you're causing a stress, right? You're causing a strong source limitation. And the bad surprise would be that some of the clusters that are developing will actually turn into tendrils. And this is one of the worst things that a great grower can actually see, because having your clusters basically disappearing on the way is a bad experience.
Qui ci sono le conclusioni. Allora, il ritardo di germogliamento è variabile da 4 a 9 giorni, il ritardo di maturazione è andato da 5 a 23 giorni. Quindi è molto interessante questa cosa. Attenti a non tardare troppo con l'intervento di potatura tardiva, perché se voi andate ad asportare troppa superficie fogliare, poi ricadete in un problema di riduzione eccessiva della resa, della produttività. La regola che invito tutti a seguire, sia che si tratti di Guyot, sia che si tratti di cordone speronato, è quello di intervenire non oltre una, massimo 2 foglioline spiegate sul germoglio apicale, non oltre questo limite. Per darvi un'idea, sono circa 4 centimetri di lunghezza, non di più. Se poi volete applicare per motivi logistici, per carità di Dio, so benissimo che c'è il grande problema dell'organizzare il cantiere di potatura, di avere le persone disponibili al momento opportuno, per carità di Dio. Tutto questo è vero. Se volete organizzarvi con la potatura in 2 tempi, lo potete fare tranquillamente, avrete un effetto sul ritardo di germogliamento, non avrete probabilmente un effetto sull'intero ciclo, però quei 2 tralci che tenete dopo la potatura invernale, lunghi e verticali.
The second practice, which is the precision irrigation for the vineyard. And it's an experiment that has been conducted by Davide's University, the University of Milan, together with another winery, Faghettina, who is in the Franciacorta region. And there is, sorry, a first, before we give the testimony, I would like to ask Davide to give some element and context on the Franciacorta.
Just share my screen.
The Franciacorta region, and especially how it copes with the water scarcity.
Okay. Okay, so the main issues in Franciacorta areas is the increasing of temperatures. As you can see, okay, in these graphs, in the last 20 years, there is an increasing of the Winkler index, so a general increasing of temperatures, while the hydrological year precipitation are the same. There is no trend for the precipitation. And these higher temperatures promote more evapotranspirations. So in the last years, wine growers in Franciacorta experienced more water stress phenomena. So this is a big issue for the Franciacorta area.
Thank you, Davide. So now I'm going to go through and show you a testimony of Enrico Rivetti, who is the agronomist of Fergetina, who is the farm where the experimentation that David has conducted was done. It's a farm of 200 hectares.
Grazie. In questo progetto e in maniera molto semplice abbiamo sposato questo progetto proprio per capire come riuscire su una base spumante ad avere le uve, tra virgolette, perfette con questi continui cambiamenti climatici, con questa difficoltà di regolare l'irrigazione, nonostante da noi sia vietata, ma cerchiamo comunque di avere una base spumante estremamente perfetta da portare in cantina, proprio considerando questo discorso di irrigazione di precisione, chiamiamola così. Noi abbiamo
non è che sia proprio vietata, è consentita in alcune circostanze.
Esattamente, sì, si è vietata nella parte, diciamo, normale della stagione, è considerata solo invece nella parte, diciamo, di assenza forte di siccità permanente. Quindi noi abbiamo un'azienda che si struttura su più di 200 ettari in 11 comuni della Franciacorta, e questa grande differenza ci permette poi così di incontrare questa esigenza di trovare il giusto equilibrio tra le viti, le uve e proprio il discorso dell'irrigazione. Veniamo da periodi di forte siccità che poi vanno a incontrare forti piogge o periodi addirittura molto così, come dire, perturbati, come è proprio questa stagione. Veniamo da un febbraio-marzo molto piovoso, scusate, molto siccitoso, e adesso perturbazioni continue che arrivano sulla Franciacorta. Quindi con questo progetto cerchiamo proprio di capire quello che è la possibilità di seguire meglio le nostre vigne.
Okay, I'm back with you. And I would like Davide to take the hand to explain the methodology and the result, unless somebody already have a preliminary question about what has been shown before. No questions? Okay, go on, Davide.
Okay, thank you, Céline. So farmers have different strategies to face water stress depending on the time frame considered and the intensity of the water stress, as you can see in this table. Particularly, irrigation is a long-term solution suitable for high water stress intensity. And this is a quite new technique in the European vineyards, where about the 10% have irrigation. But however, there is some water-related issues. First of all, the scarcity of this resource, but also the competition between the different sectors, between industry, between civil users, and between agricultural users. And finally, the water is a cost. The water use is a cost for the farmer. But we have also some some irrigation-related issues. First of all, the farmers have to follow the regulation of the local appellation, as Enrico said in the video before. But for a correct management of irrigation, several information is needed. The farmers have to decide when irrigate, how much water give to the vineyards, and they have to decide the threshold to start irrigation, taking into account of the quality and yield goal of the company. And finally, we have the spatial variability of water demand inside the vineyards, and this is another another point to take into account for irrigation. So the goal is to optimize the water use, and the precision irrigation allow to reach this goal. Particularly in the VIRECLI project, we design and manage a variable rate drip irrigation system. The experimental site was in the Franciacorta areas, is a 4.5 hectares vineyard. The vineyard is almost flat, and the cultivar is Chardonnay, and the company produce sparkling wine. About the methodology, in the first year, the 2020, we detect the spatial variability of the vineyard, and we design the variable rate irrigation system. And in the next 2 years, we manage this irrigation system using a DSS. And of course, we also evaluate the performance of the vines inside this treatment. About the first step, the design of the irrigation system, the first step is the soil characterization. We use geophysical techniques based on the electrical resistivity. And after this analysis, we are able to divide our vineyard in 5 homogeneous zones. And after a pedological analysis, we can have the soil, the characteristic of each soil units. And particularly, as you can see in these graphs, these are the soil profiles. We have 2 units with short profile and less structure and less water capacity. And these zones are characterized by a high water demand, while the other type of soil are more structured, and they have less problem in water stress. So the soil in blue, in green, and in yellow form the low water demand area. But there also, of course, a response of the crop. So we detect the response to the crop to an homogeneous management, as you can see in the figure, in this map, and also in this. Inside the vineyard, we have a difference in the water stress, difference in vigor, and of course, different in the acidity at the harvest, and different in sugar. So homogeneous management of this type of vineyards promote more variability inside it. In light of all this consideration, we design our variable rate irrigation system. We divide the treatment, the zone, in 2 areas, a high water demand area and a low water demand area. This is a single drip line along the row. Drippers have the same flow rate, but the distance of the drippers change along the line. So in the high water demand, we have a 60 centimeters spacing drippers, and in the low water demand area, we have 120 centimeters spacing drippers. So in the high water demand areas, we give more water than in the low water demand area. We compared this variable rate irrigation system with other 2 treatments, non-irrigated treatment and the company standard. That is an homogeneous irrigation, and here you can see the characteristic of the irrigation system. About the management, the variable rate treatment was managed using a DSS based on the soil-water balance, and we also validate the DSS alerts in order to calibrate the DSS. We calibrate and validate the DSS using thermography, detecting the photosynthetic activity, and using a pressure chamber. About the result, the first is a 17% water saving using the variable rate technology compared to the farmer standards, and the results are similar in both years. But again, against this saving, the production and qualitative results do not show significant difference among the treatment. As you can see in these graphs, no difference in acidity, no difference in sugar content, no difference in pH, no difference in yield. This is for the 2021 season, but the same is for the 2022 season. And once again, there aren't significant difference between the quality and the yield parameters of the crop. But focusing more on the results, we can see the more interesting results are focusing on the different water demand areas. Generally, in the variable rate technology, in the variable rate irrigation treatment, the difference between the low water demand area and the high water demand area are reduced. For the yield, for example, only 0.5 kilograms difference, while in the other treatment, this difference up to 1.2 kilograms. The same for the sugar, no significant difference in the variable rate technology system, while they up to 4.5 bricks in the company standard. And once again, for the acidity, only 2 grams per liter difference in the variable rate, while the difference up to 4 grams per liter in the company standard, and the same for the pH. So some take-home message: grapevine yield and quality is very responsive to water nutrition. The variable rate irrigation allows to save water through a better fit to plant water demand, and to increase the homogeneity of yield and quality of grape inside the vineyards. The innovation of this approach is to the detection of space variability using commonly available geophysical technique, and the variable rate irrigation implemented using a single drip line instead sectors. About the applicability, after this proof, a winery in Chianti Classico area in Tuscany decided to use this approach to implement a variable rate irrigation in 15 hectares of vineyards. And thank you for your attention.
So let's go back to the cinema and see the other part of the movie after the testimonial.
Irrigation system makes it possible to maintain production and quality standards even in the most difficult years by optimizing water use. In 2022, despite severe droughts, it enabled areas with higher water requirements to achieve higher production with qualitatively better grapes. In 2021 and 2022, precision irrigation flattens the differences between areas of different vigor, achieving more 0.4 kilograms per plant in the low vigor area versus on-farm irrigation. Also in the qualitative aspects of the musts, for acidity, the differences between the two vigor areas are drastically reduced due to higher values in the low vigor area, with the gap thus reduced to just over 2 grams per liter, as opposed to 4 grams per liter in the other theses. Variable rate irrigation management has resulted in an average savings over the 2 years of 15.5% compared to the farm standard. The savings resulted from a 28.5% increase in volumes in low vigor and a 35.5% reduction in high vigor, thus better fitting the needs of the plant. A careful analysis of soil characteristics and their variability within the vineyard should be performed using state-of-the-art technologies, such as those based on the acquisition of electrical resistivity, a quantity strongly correlated with the main physico-chemical parameters of the soil. The indications thus obtained allow the vineyard to be divided into homogeneous zones, within which the hydrological properties of the soil are uniform. Each homogeneous zone will eventually be characterized through a soil survey. The entire service is offered by specialized companies. Supported by the data, the design of the variable rate drip system involved the creation of 2 zones, achieved by laying a single drip line characterized by a different pitch between the drippers, greater in the high vigor zone and less in the low vigor zone. This solution was adopted by applying hydro clips on the drippers, so as to close them and modulate their pitch. At each irrigation intervention, it was possible to distribute less water in the first zone than in the second, thus accommodating the different water needs due to the difference in soil. 2 decision support systems were used during the trial, Irriframe and MANA. The first is an ANBI National Association of Irrigated Water and Land Management and Protection Consortia project, with technical agronomic coordination by SEER Consortium for the Emiliano-Romagnolo Canal. This system is powered by a water balance model and bases the irrigation advice on simple parameters to be implemented. MANA, on the other hand, is an SSD developed by Rivulis and uses frequently updated high-resolution satellite data. These, combined with highly localized weather information, allow for site-specific irrigation advice. The system also allows for periodic maps of ENVI and soil water status, again calculated from satellite data.